I will now explain the lower portion of the overhead panel located over here. One thing I will do slightly different in this tutorial and in the rest of the series is that I will no longer point out any buttons, controls, or knobs that are not functionally implemented and are there just for visual realism. This is so as to prevent having to say that so-and-so control is not implemented repeatedly throughout the tutorials. If I omit explaining something, it is because it's not functionally implemented in terms of the explain model of the aircraft. With that said, let's begin. These are ventilation fans that can be turned on using this switch on the nav2 panel. You can use them if it gets hot or stuffy in the cockpit. I'm not sure that that's a concern in flight simulation, but it is a nice touch of realism on the author's part. I'll go ahead and turn them off and take the nav2 panel away by pressing the nav2 button on the main menu bar on the left. These are the COM1 and COM2 radio control panels. I pointed out in the last tutorial how they can also be accessed via the 2D radio panel. Setting their frequencies is done by using their respective larger, lower knobs. This area is used to control the radar screen that is located on the middle frontal cockpit panel, which I showed you in my cockpit introduction tutorial. These buttons control the radar scan speed. The upper button increases, whereas the lower button decreases the radar scan speed. This is the radar power switch. The lower power button is off and the upper power button is on. Before turning on the radar, always make sure that it is in the ready mode by using this radar mode selector knob. Only 3 of the modes shown are implemented. They are ready, medium, and slip. Once the radar is turned on, the green light glowing by the ready mode indicator means that other radar modes are now available. The meteo or weather mode is used to see pockets of storms that may be in or around your flight path. Let me go ahead and turn it on to the meteo mode. So first I start with the radar off by pressing this button, just to show you how the procedure is. I'm going to go ahead and turn it off. The first thing I will do is I will turn the radar on by pressing this button and make sure that before you turn it on you have it in ready mode using this knob. So I'm going to go ahead and turn it on. Now the green light comes on, indicating that other modes are available. I will go ahead and change this to the meteo mode, and you can see on the radar screen below the scanner is now active. I can increase the scanner speed by pressing this button repeatedly. The other radar mode that is useful is the drift mode, which only works when you're in flight. Therefore I can't demonstrate it to you here. The drift mode shows the true direction of flight. Drift mode can be helpful if you have the aircraft in a large crab angle, such as when trying to land in a strong crosswind, because in such a case, the direction of flight may be different from the direction that the aircraft is pointed in. These knobs are used to control the radar display brightness, contrast, and indication brightness, respectively. You can experiment with them on your own until you get the radar screen to look exactly as you like. And remember, the radar screen can be swiveled by clicking on it so that the first officer or the captain can see it. By opening this cover, you gain access to the auto-feather test controls for the engine propellers. Before I proceed further, just to be fair to those who do not understand what propeller or engine feathering is, let me first show it to you because it is far easier to understand what is being discussed if you have first seen it in action. Please watch the following animation. The aircraft's right-hand side propeller is currently in what is called the unfeathered or the working position. That is the position you would normally want the propeller to be in while the engine runs. However, there are situations when it is better to feather the propeller, especially during an in-flight engine failure. When it is feathered, as it is now, each propeller blade rotates about the axis defined by the propeller blade's tip and root. After being feathered, the propeller blades do not face forward as in the working position. Rather, they are facing sideways or are aligned parallel to the wind stream of the flying aircraft. Here is the propeller unfeathering again, or returning to the working position. You would want to feather a propeller in case of engine failure to minimize unnecessary drag that is produced by a windmilling propeller. And feathering prevents or greatly reduces windmilling, so that you don't have to worry about feathering the propeller in certain critical situations, for example, engine failure on climb out. There is the auto feather system to handle this for you. Without getting into details beyond the scope of this tutorial, the auto feather system basically feathers the propeller blades of an engine that ceases to participate in propulsion of the aircraft. It is my hope that this digression will help you better understand the controls I will explain to you next. Let's get back in the cockpit to look at the auto feather system controls. Here are the auto feather annunciators for the propellers. The left lights are for the left propeller, and the right set of lights are for the right-hand side propeller. The top two lights indicate that the propeller is transferring from the feathered to the working or unfeathered position. The middle set of lights indicates that the auto feather system is armed, meaning that it will activate and feather the propeller if engine failure is detected. The auto feather system gets armed when you advance the throttle beyond a certain position. Let me go ahead and advance the throttle. You hear the engines revving up and you see that the auto feather system is now armed. I'll go back to idle throttle. The lower set of lights indicate that either the respective propeller is feathered or a feathering test is in progress for that engine. These two buttons are the propeller feather buttons. Pressing them in feathers the respective propeller, and popping it back out unfeathers the propeller or puts it back in the working position. These buttons are what I used to prepare that animation that you just watched. The lights in these buttons indicate that either the propeller is feathered or that the engine has failed. Right now I have both engines running healthily. Let me go ahead and press one of them. And you see that that engine comes to a stop, and you will notice that the propellers are in the feathered position. Back on the auto feather panel with both engines running healthily, these are the auto feather system testing switches. The left side are the left and right propeller normal thrust auto feather test, whereas the right hand side switches are the left and right propeller negative thrust testing switches. When you press a switch up, you will notice that both red lights corresponding to that engine go on, the auto feather annunciator and the auto feather button light. One indicates that the engine is feathered, the other indicates that the propeller may be feathered or the engine has failed. When you see both of these lights come on for the appropriate engine as you test the auto feather system, that is an indication that the auto feather system is working. Before we discuss the controls of the fire protection system of the An-24, I'd like to show you something that might help you better understand why they're laid out in the cockpit as they are. The fire protection system of the An-24 has 4 fire extinguisher charges available. 2 are dedicated as one for each engine. These are represented here by the purple rectangles. The other 2 fire extinguisher charges are for the various checkpoints around the aircraft that are monitored by fire detectors. These 2 charges are represented by the red rectangles. The monitored checkpoints are the left engine, the right engine, the left wing, the left engine nacelle, the right wing, the right engine nacelle, and the auxiliary power unit, or the APU, also known as RU-19. Should a fire be detected in an engine, you will have to manually discharge the appropriate fire extinguisher for that engine. Now, if a fire is detected in any of the other checkpoints, then the first fire extinguisher charge will automatically discharge at that location. If needed, you may discharge the remaining second charge, but this has to be done manually. Let us now return to the cockpit and see the controls that do that which I have just described. The fire protection system of the An-24 is controlled by this area. These are the annunciator lights for the 5 non-engine checkpoints described earlier in the diagram. that were represented by the red dots. These annunciator lights also act as buttons. Note that this annunciator light has a typo in it. It says engine instead of nacelle. I fly the older version of the An-24, so maybe in the newer version or the RV version this typo has been corrected. These here are the fire annunciator lights for the engine fire detectors. They were represented by the purple dots in the diagram. These lights do not act as buttons. This button is the fire extinguisher discharge for the left engine, and this one is for the right engine. Please note that an engine with discharged fire extinguishers cannot be started again. Furthermore, a burning engine may be kept running for no longer than 1 minute before there is risk of fire spreading to the wing and other surrounding structure. This is the main system switch for the fire protection system. The up position means the system is armed, the middle position is off, and the down position is used to test the system. These yellow lights are the fire extinguisher charge ready lights for the left engine, the right engine, the first charge of fire extinguishers for the 5 non-engine checkpoints, and the second charge of fire extinguishers for the non-engine checkpoints. I will now give a demonstration of how to extinguish a detected fire on board the An-24. I will simulate that we have a fire in the APU unit by pressing this button, which is also an annunciator light, as I stated earlier. Note 2 things happened. The siren came on, which I will silence by acknowledging it by pressing this button, and the first charge of fire extinguishers has been discharged as indicated by these lights going out. This charge was represented by one of the red rectangles in the diagram earlier. Now say I want to go ahead and use the second charge as well, since the fire may not be out. To do this, I must first press the annunciator light, silence the alarm again, and then use this button to release the second charge, which was the second red rectangle in the diagram. These lights going out indicate that the second charge has now been used up. The other 4 non-engine checkpoints have an almost identical procedure for extinguishing their fires. The engine fire procedure is a bit different from the other 5 checkpoints, and I cannot simulate it fully unless there is an actual engine fire. But I will go ahead and show you how to discharge an engine fire extinguisher. Upon fire detection, the fire protection system will light the corresponding engine's fire annunciator light. Let's say we have a fire detected in the left engine. I'll put it out by pressing this button. Note that these lights go out, which means that the extinguisher charge for the left engine is now used up. And most importantly, the left engine is now inoperable. You can see here that it's winding down to a stop. This device here is simply a magnetic compass, also known as the KI-13 on the An-24. However, note that the cardinal points on this compass seem to be labeled in Russian alphabet, perhaps because the author does not design a Western version of the instrument. However, it is easily readable and usable like in any other aircraft. But beware, do not rely on this device unless the aircraft is in level and unaccelerated flight. This isn't just for the An-24, but rather a rule when dealing with magnetic compasses on board aircraft. This is one reason why aircraft have directional gyros. We are now done with our study of the overhead panel.